example here to finish off. So this is second moment of area, units of meters to the 4, which you can see because you've got B by H by H by H, so that's 4 of them to the power 4. So we're looking to approximate the error in this calculation when the height. Now, actually, oh yeah, so it does say it. Okay, so our best approximation, we should just throw in what we think. Call this I0. So the base, we're coming up with 2.2 times the height is 0.8 cubed divided by 12. And we'll throw this into a number of significant figures at the moment. 2.2 by 0.8 cubed all over 12. So that's coming in as 0.09387 meters to the 4. Okay. Okay, and we don't loads of space above and no space here. So let's see how we got. What I might just do here is, oh God, I'm done for space. So we're going to come up here. Sorry about this. So the error in that calculation is the maximum absolute value of the differential, which is the derivative with respect to the first variable, which is the base, times the error in the base, plus the derivative with respect to the height, times the error in the height. Okay, and everything is positive here, so the absolute values are going to disappear. Now, in terms of differentiating this thing, what you should see the division by 12 as multiplication by 1/12. Okay. That is the same thing, like dividing by 12 is multiplying by 1/12. That'll help the differentiation. So again, sorry about the space here. So differentiating with respect to B. Now, so I'm going to forget about the absolute values because everything is positive, and differentiate with respect to B. So with respect to B, you've got a constants 1/12 and H cubed. And what's the derivative of B with respect to B? 1 times the error in B. Plus, now differentiate with respect to H. So we've got constants 1/12, fix the constant B, and the derivative of H cubed with respect to H is 3H squared times the error in H. And again, sorry about the space here. So we're going to bang in all the numbers, 1/12. So the derivatives are evaluated at the measurements. So height 0.8. Derivative of, sorry, not the derivative, the error in the base. Well, both of the errors are 1 centimeter, which is 0.01 meters, plus 1/12. The base is 2.2 times 3 times the height, which is 0.8 squared, times the error in the height. Oh yeah, we said both of the errors are 0.01. So we'll bang that into the calculator and see what we get. 1/12 by 0.8 cubed by 0.01 plus 1/12 by 2.2 by 3 by 0.8 squared by 0.01. Just going to check that the other error right. Yeah. And this comes out to be 0.003947, which rounds to one significant figure, 00. Now the 3 rounds up because it's 39. This. So the one significant figure there is the third decimal place. So we should match the precision here. So we're going to say that our calculation of the second moment of area is 0. So round this thing to 3 decimal places, 0.09. Now the 8 rounds up the 3 to a 4, plus or minus 0.004 times meters to the 4. Okay. So I think one of the things I'm just going to show you is just in the exercises, they're what are called interleaved. So you kind of get different things coming in. So the first question is differential, so is the second question, but then so is the third question, but then you've got parametric differentiation, then you got implicit, then you've got partial differentiation, then you get more differentials, more partial differentiation. So you just get this mix. And so this is like a revision exercises at the end. Okay. And there's also a summary here. So if you're really struggling to understand the differences between the questions, or rather the topics, this is probably a good place to look. The difference between parametric and implicit, it just gives a slight explainer there, and everything else. Okay, so that's chapter 3 done. And the test will be week 11, which is after Easter. So it's plenty time away, plenty of time for you to put time into this chapter.